So this is the tracking folder we have, and in this we're going to work it. So simply open this folder in VS Code Studio, and you can see we have opened the folder. Now bring your terminal up, and we have to initialize the project. So the very first thing we have to do is we have to create a next app. So this is the command we're going to type: npm create next app .n. We're going to hit enter. So this will create the project in the same directory, and in this project we're not going to use TypeScript or SLint, so say no, and this will create the folder and file structure which we need for this project. So just wait for a moment, and here you can see we have successfully initialized the project and we have created all this folder. So simply go to the pages. Inside the pages you will find all this API folder, app, document, next.js. So you can see we have all of these one. So there's document. If you compare the public, this is the style file. Inside that, this is the package.json file, and that we will have all the packages will install. And now we have to simply run this, and we have to see that everything's working fine. So type npm run dev. You can see we have started the application in localhost 3000, and it looks pretty good. Everything's looking good. Okay, so we have successfully initialized next app. Now what we have to do is stop the application from running, and we have to do a couple of setups. So first we have to come into the pages, and we have to delete all the folders, all the files, all the code which we don't need in our project. So we're going to simply delete this API folder because we are not dealing with an API. Now come to the document, delete this one as well. Come to the index, and we have to remove all of these codes. Remove the type RAFC, and this is the general setup we have. Looks pretty fine to me. Now let's come here, go back to the styles, and we have to delete this one, home modules, delete this one. So this is the CSS file we need to delete. Close it. In this project we're going to use Tailwind CSS for installing all the components. So here I'm on tailwindcss.com. make sure to come here, and we have to click on get started. So from here you have to select the framework which you want. So I will go to framework, and here we're going to choose next.js. We have all of this framework, whichever you are comfortable in you can select that, but we're going to use next.js, and these are the configuration we have to do. So we have successfully initialized the project. So now we have to simply install the packages. So grab this one. So we have already done this. Now grab this one, come here, and we have to paste and install the packages. Now we have to initialize the Tailwind CSS. Type it, and here we have initialized Tailwind CSS. Open this one, and this is the predefined code which Tailwind CSS creates. We're going to replace this code with some configuration, and this is the post CSS. We don't need to do anything in here. Looks fine, and this is the configuration we have to do in Tailwind config file. So simply grab this code, copy this entire code, and simply replace with this. Looks fine. So that's the only setup we have to do. One more we have to do. Now we have to utilize this global CSS. Okay, so this will allow us to use the extra classes, the custom classes we want to use in this project. So simply grab this one, and this is the one we're going to paste inside this global CSS. So I hope this makes sense to all of you guys. Okay, so looks fine. Now we're going to simply grab this one to check whether it's working or not. So grab this one, come back to the index, and here we're going to paste. And now we have to start the application. Type npm run dev and open the app. So you can see, reload the browser, and our Tailwind CSS is working fine. So our text is bold, and we have another line. That means it's working. Looks pretty fine to me. So now we're going to install Hardhat packages, which allow us to write the smart contract, test the smart contract, and deploy the smart contract. So here I have opened Hardhat. Make sure to open it, and these are the commands you have to write for installation. So you have a couple of options. You have npm 6 yarn, but we'll go with the npm. So this is the thing you have to copy. So once you run this, it will create a dev dependency, but simply grab that one, and let's come here. Let me clear the terminal, and let's install it. We'll type npm I Hardhat. So this is the command you have to run, and this will install the Hardhat package in the project. So just wait, this will take a little bit time, and you can see once the installation get completed, you will find the packages here. So it's taking time. Now what we have to do, come here and we have to go to the Ether.js, because this package we also need, and this package is really powerful. It's allow you to interact with a smart contract and communicate, make the connection with Ethereum and through the RPC world, and it's other provide other options as well. So if you are new to Ether.js, I have a complete project, I have a complete tutorial on Ether.js. I'll link in the I button in the description, so you guys can follow that if you really want to know more about this library. So click on the installations, and these are the commands you have to run. This is how you can utilize it in your project, so you can have a look from your end. Okay, so I'm going to show you everything from the beginning, and now we have to come here. We'll type Web3 model. This is the one more package we're going to utilize, and this package will allow us to connect the wallet. So all you have to do is to import the package, and you can easily able to connect with any wallet. So you can see it's pretty easy. So looks fine. You will have a couple of examples which you can follow. Click on docs, and here you will find that information about the doc. So we have installed Hardhat. Now we have to clear the terminal, and we have to initialize Hardhat. So type npx Hardhat, and this will initialize the Hardhat. Now we have to select the project type. So whether you want to go with TypeScript, JavaScript, or empty Hardhat config file, but we go with the JavaScript project. Hit enter and hit enter, and this will install the necessary packages which you need. So you can see we have installed the packages. Now clear your terminal, and now we have to do certain things. So we have to install the packages. Okay, so we have to install Ether. So we have to install Ether, and this is the exact version you have to use. I don't know why when I was testing with the latest version I was getting an error, like when I was interacting with the Web3 model. Okay, so I was getting error, so that's why I will go with the specific versions. If you're watching this video after a year or a 6 month, then make sure to follow the exact version, otherwise it will not work. So we'll use 5.7.2 version. Hit enter, and this will install the packages. And now we have to install the last package, which is a Web3 model. Type I Web3 model, and you have to pick the exact version. Okay, that looks fine. And here we have installed all the packages, and all the information about this packages you will find in the package.json file. If I scroll down, you can see we have dev dependency, we have dependency. Okay, so these are the packages we have installed. So looks fine. Close this one, and close this one, close this one, and we are done almost with all the setups. Now we have to create the folders and file. So let's come here, close this one, and let's click on the main directory and create a folder. We'll create a folder by the name component, and in this we're going to create all the component for our applications like table, navbar, footer bar. So this is the component we have. Now we have to create one more component, a folder, and this we're going to manage our context API. That's why we have called context. Now this looks fine. We have the two folders, but right now we're not going to create the components. We're going to work on the smart contract and the context. So click on the smart contract, and this is the contract, pre-existing contract we have. So what we have to do is we have to delete this one. So delete this contract, and we're going to come to the script folder, and that we have to do the configuration. So you can see there is so much mess in this deploy script, but we need a clean deploy script. So delete this comments. We have to delete some extra codes from here. We don't need to pass, we don't need this one as well. And come here, we have to simply remove this because we don't need that one, and we'll say, let's say tracking. Okay, that looks fine. So we're going to make the changes in the file name. Okay, we're going to make changes. So this looks fine, and this is the component we have, this is the context we have, and this is the contract folder we have. Now let's create a folder file in the contract, and we're going to call tracking.sol, because that's the contract we're going to build. So that's the file we have, and now let's start writing the smart contract. So first we have to import the license identifier. Actually we have to type the license identifier, not import. Now we have to define the pragma solidity version, which we going to take it's 8.0, and now we have to initialize the contract, and we're going to call it tracking. In that we have to define the enum, because our tracking model will have the status system, like it's in delivery mode or delivery completed, or it's in between the delivery. Okay, so that's the enum we are to define. So So shipment status is going to be a pending, in transmit, and deliver. So these are the three status of the product we'll provide. Well, come here, we're going to take the struct, and that we're going to keep all the information about the product. So the first thing we have to keep is the address of the sender, the one who is sending the product. The second is going to be the address of the recipient. The third one is going to be the pickup time, when the package will be pick up. Then we'll have the UNT is going to be delivered time. So when the package will be delivered, the product will be delivered. Now we'll have this distance. What is the distance? We'll have the price. We'll have the shipment status. Initially we're going to pass this status, and from there we're going to pick it. So we'll say status, and we're going to take this boolean is paid. So this will keep the track of whether the payment is made or not. So that's the start we have. Come here, we have to take a mapping. It's going to be address type, and it's going to keep a track of the shipment. So this address will give a single shipments data. It's going to be a public shipments. We have to take a UNT, and this will keep the track of number of shipment we are doing. So that's the one we have. And now we have to take the struct, and in this we're going to do all the experiments. So this struct I'm taking because sometimes we have to modify certain data to display on our front end. Okay, you can go with the previous data, the previous struct, but I try to keep things simple, so that's why I'm taking this approach for creating another struct for the display purpose. And in this we're going to define all the data exactly the same. So we're going to provide the address, sender, recipient. We're going to provide the UNT, the pickup time. We have to provide the delivery time. We have to provide the distance, and we have to provide the price, and it's going to be a shipment status, and the last one is going to be is paid. So that's the entire struct we have for the type shipment. And we have to take the array as well. So it's going to be a type shipment array, and it's going to be called type shipments. In this we're going to keep the entire shipments data, so we can fetch it and we can display in the front end. Now we'll come here, and now we have to take the event. So we have to initialize all the event. So the first event we have this create shipment, and that we are taking the address of the sender, recipient, and the price, a pickup time, distance, price. And you can see that I have used this event in one place, two place, and only two place. But in event you can pass 3 indexes for filtering the data, but not more than that. So this is the first shipment we have, events we have. Now let's create the other event. We have this in transmit, so when the product is in delivery. Okay, so we're going to pass the exact data. Now we have this shipment delivered, so when the delivery is completed, in that we have to pass the exact data about the shipments. So these are the 3 events we have. Now we have to take one more. This is called shipment paid. So we have to pass the exact data, sender, recipient, and we have to pass the amount. So these are the events we have, and now we have to define the constructor. So we'll say constructor, and in that we have to simply increase the count to 0. So we have to define the 0 variable. You can go with the straightaway variable, but here I'm updating with the help of constructor. So that's the constructor we have, and now we have to write the functionality for our smart contract to make all these things happen. Okay, so let's come here. We're going to create a function by the name create shipment, because that's the very first function anybody can call. After that they can call the get data, update data, start data, but they need to have some but before they call any one of those functions, they have to create the shipment. So in the create shipment we have to pass couple of data. We have to pass the receiver, the one who's going to receive the product. We have to pass the pickup time, we have to pass the distance, we have to pass the price, and it's going to be public and payable, so anybody can call and make the transaction. Because in this function we're going to deal with the price, the money. So now we have to check for a condition. So message.value is going to be equal to the price. If it's less or higher, then we have to throw the error message. Payment amount must match the price. So that's the first condition we have. Now we'll come down here, and here we're going to simply update the data in our circuit. So we'll take a memory shipments, and we're going to identify based on the sender, the one who's calling the function, and in that we have to simply pass all of this data. We have to pass in the shipment. So sender, time, distance, price, and status is going to be pending. When the shipment will create, it will be a pending, and paid is going to be false. So this is the data updating. Once we update the data, we're going to simply take this message.sender is going to be pushed into the array, so the array we have created. That looks fine. Now we have to take this shipment count and we have to increase, because this will keep the track of how many shipments we have created in the contract. So that's the create function, and we'll come here. We're going to take this display array data and we're going to push the entire data into our types system. Okay, so simply let update the data. So we'll take this type shipment and then we're going to simply update message.sender, the one who's calling the function. We have to update the receiver. We have to update the pickup time, amount, we'll have the distance, and we're gonna have the price. We'll have the shipment state is going to be pending, and we'll have the false paid is going to be false. So that looks fine. So this is how we have updated the data, and so it looks pretty good. And now we have to simply close this one and come down here, and we have to initialize the event shipment created, and we have to pass sender, receiver, pickup time, distance, price. So these are the 4 data we are taking, and we have to simply close the function. So that's the function we have for creating the shipment. And now we have to create the other function which calls start the shipment. So once the function is got created, it will be hold in the contract. So it will in the contract, and once the product is ready for shipment, we have to call this function to make the status, to change the status and notify the recipient and the sender that the product is ready for shipment. It's already shipped. So we're going to pass this address of the sender, we'll pass the address of the receiver, and the UNT, the index. So every single product will have an index positions, and that's what we have to pass to make the shipment start. Okay, we'll say public, and in this we are not passing any payable keyword because we are not making any transaction with the money. So public, we'll come here, and here we have to check the, and here we're going to simply update the status. So we'll say shipment storage shipment, and we're going to find the particular shipment based on the index. So once we have that particular shipment, we'll come here and we're going to simply take this type statement because we have to update the data as well, and it's also we find on based on the index. So once we find in both the data, we have to simply update it. So we'll say we'll say shipment dot receiver equal to the recipient. So this is how we can validate that they have to provide the receiver address to match this condition. So receiver, now we're going to simply pass this receiver shipment status is going to be a shipment pending. If it's not pending, then we don't allow them to call this function. So I believe that you guys can understand the logic we have tried to build. So this function is going to be called once the shipment is created, because this will define the product is ready for dispatch or it's dispatched, and that's why we are changing the status from here, and we are checking that if the status is deeply equal to the pending, then we have to call this function. But if anything it will be something then this like deliver or transaction, then we want to fail the function to call. Okay, so that's the second check we have. We'll take this shipment and we're going to change the status to in transmit because it's ready, it's dispatched for the delivery, and we have to simply update the data here as well. So that looks fine to me. Now we'll come here and we have to initialize the event for the in transmit, and we have to simply pass the data sender, receiver, and pickup time. Close this one. So this is the second function we have created. So the first function for creating the shipment, and the second function we have for starting the shipment. Now we have to create another function. We'll call function, we'll complete shipment. So once the shipments got delivered, they have to call this function to change the status of the product and make the transaction. So we'll say complete shipment. It will take the address of the sender, receiver, and it will take the index. That's how we can identify the particular product. So now we're going to take the data. So we're going to find that particular shipment which they have deliver, so which we have inside the shipment storage. And the reason we have taken the storage keyword because we are making the changes in the state variable. Okay, so when you are fetching and displaying the data without making any changes in the state variable, in those scenario it's better to use memory, because memory will refer to the creating the data in a memory field, so you can easily able to call and you don't need to pay any amount. But when you are making the changes in the state variable, and that time it's always very important that you have to use the storage keyword. So we'll find that particular shipment in the shipments, and we're going to pass the sender and the index, so we can get that particular. And then we have to simply do the same thing for our types shipment data. Okay, this looks fine to me. We have found the particular shipments, and now we have to check for a condition. So we have to check for the condition that message shipment receiver is going to be equal to the recipient, the one whose address is provided. If it's not, then we have to throw the error message. So that's the condition we have. Now we have to check for another condition, that we have to check for the status. So the shipment status should be in transmit. Okay, if it's not, then we have to throw the error message. And then we have to check for the third condition, that it's not paid. Okay, it has to be false, not true. Already paid. If it's true, then it's already paid. Now we have to make the changes in the actual data. So we'll call this shipment status to deliver, and we have to simply update this type shipment also to a delivered. This looks fine. Now we're going to take this type system deliver time. It's going to be a block timestamp. So the moment this function is getting called and the shipment is completed, and we have to simply update the deliver time as well in the actual state. And we'll take this unt, we'll say amount is going to be the price, and we'll say payable shipment sender, and we'll say transfer the amount. So we'll simply transfer the amount to the sender. This looks fine. Now we're going to say this is paid true, and we have to update this in type shipment as well. So I believe that you guys have understood that what we have done here, and we have to initialize the event for the deliver shipment, and that we have to pass the sender, recipient, shipment, delivery time, and looks fine. And we have to initialize the other event which is paid, and that's it. So hope the entire contract makes sense to all of you guys, that what we have done. First we have tried to find out the particular shipment. Once we get that, we are simply updating the data, and we are doing couple of checks. Once we have done the checks, we are transferring the fund to the sender, the one who is calling the functions, and then we are simply making all the changes in other state variable, and we are initializing the event. Simple, very easy. So this is the third function we have. Now we start with the another function. We'll say function get shipment. So this will allow us to get the data about the shipments. So in that we have to pass the sender address, and we have to pass the index of the particular shipment. It's going to be a public, and view return, because we are not making any changes, and view is referred to checking the value of the state variable. You can't use it pure, because pure use for local variable, but you cannot use for state variable. And we have to return the address. We have to return the address and unt, and shipment status and bool. So these are the data which we have defined in the struct. That's all the data we have to have with this function. So we get it. Now we have to find the particular shipment which a user trying to get access, and that's we can do it based on the index. Once we have the data, now we have to simply return the entire shipments, and that we have to simply pass the shipment sender, shipment receiver, shipment pickup time, shipment delivery time, shipment distance, we have the price, we have the status, we have the paid. So we are passing all the data we are taking with this function, and that's pretty much, and that's the only thing we have to do inside this function, which will allow us to give us the data for the particular shipment. So that's so full. Now we have to write the other function. So let's create that. We'll say get shipments count. So this will allow us to get the number of shipments created. Okay, and we'll say address sender. So this will do on based on the users. Just imagine that I'm a user of this applications, and I have created a 4 shipment. So this function will allow us to find out that how many shipments I have created. because ultimately it's a marketplace. A lot of users can come and create the shipment, so we have to have a function which allows the user of the application to know that how many shipments they have created, and it's going to be a public view return. And in that return we have to return the unt, because we have to display the number of the shipments. And here we're going to simply return the shipment dot sender and length, and this will give us the data that how many shipments he or she has created. So that looks pretty fine to me. Now let's come here. We have to create one more function. This will call get all transaction, and this function I'm creating specifically because I want to fetch all the transaction which got created in the marketplace, so I can display in the tables. In that I have to simply call this functions, and we'll say public view will have the return, and that we have to return the entire array. And we are using this memory keyword because we are creating the data in the memory when the function is getting called. That's the thing you have to keep in mind. You cannot use storage. And in that we have to simply return the type shipments array, the entire data. Hope this entire thing makes sense to all of you guys, and simply close that. And that's the entire smart contract we have written for this application, the app we are building. So hope this entire thing makes sense. So this is the contract name we have given, this is the enum we have the entire shipment, we have the mapping, and we have all of this function we have created, get shipment count, and we have built all of this logic. So I believe that this entire thing makes sense to all of you guys. If you still have any confusion, try to rewatch, because this one is a very important part in the smart contract development for our dApp, and this is going to be the core functionality for our dApp. Okay, so that's very important to understand every single thing. So this looks pretty fine. Now you can see that. Let's come here, go to the script, and we have to change the name. Deploy, we have to change the name of our contract. So here we have log, simply select and replace this tracking, and that's the same thing we have to do here. And we have to replace this because we are not passing any argument into our constructor. So simply replace this one, replace this with a small t, and grab that one, paste here, and that's the one thing we have to paste here. So that's the entire deploy script we have. I believe that this is nothing new to all of you guys. You already know that how to do it. So that looks pretty fine to me. We are done with the contract, and now comes the most important part. So we're done with the entire one. Open up your terminal, and we have to split the terminal, and we're going to deploy the contract, and after that we're going to build the context for our dApp. So let's split the terminal in two parts, and now we have to initialize the local blockchain using Hardhat. So we'll come here, we'll type npx Hardhat node, and this will run the local blockchain in our terminal, so we can test our contract. So hit enter, and it will give you 20 accounts it will give you with account address and private key, and each account will have 10,000 ether. I believe that you already know how to import this wallet addresses in your MetaMask account. All you have to do is to take this private key, copy, and simply import in your MetaMask, and it will reflect your account address and the amount you have. Okay, so we have initialized our local blockchain. Make sure you have to initialize it before you deploy your contract, and as long as your contract is live, your app dev is live, this local node blockchain would be running. If you stop this one, it will throw you an error. So first initialize this, then deploy the contract, and then start the application. So you can see now everything is working fine. All of this we have here. Now we have to deploy the contract. So this is the command we have to write: npx Hardhat run network localhost script deploy. So we are deploying to the localhost, that's why this is the command we have to write. Hit enter, and this will deploy the contract. First it will compile your contract, and once it got compiled, it will give you the address of the contract. So this is the address we have. Simply copy that one. Looks fine. Come here, and here it will create the artifact. In that artifact you will have this contract. Inside the contract you will have the contract ABI, which allow us to interact. Okay, so that looks pretty fine. Now we're going to start. So that looks fine. We have cleared the terminal. Now bring this one down, and now what we have to do is we have to start working on the context management of our dApp. So we already have the address of the contract, and now we're going to utilize it. So first thing we have to do is we have to create a file. We're going to call tracking.js, not JS. So that's the tracking.js we have, and in that we're going to take this contract and we're going to take this tracking API and we're going to grab into this context, and that's the thing we have here. That looks pretty fine to me. Close this one, and now we can start working on our context management. So we're going to write the code in our tracking. So for a couple of packages from React, so we need use state, use effect, and that's coming from React. So that's the first import. Now we have to import the Web3 model, which allow us to interact with the wallet. We have to import the ethers, that's coming from ethers, and that's the import we have here. Now we're going to do a couple of internal imports. So first thing, we have to import the tracking, the ABI of our contract, which we have in the same directory inside the context, and this is the tracking.json. Okay, so we got our ABI, and now we have to simply paste the address of our contract. So we'll say const contract address, and this is the address of the contract. Actually, I remember the entire address. So this is the address you will get when you will deploy any contract for the very first time. So just imagine that you have a single contract, and once you deploy the contract, this is the exact address you will get. So we have the ABI, we have the contract address. Now we're going to simply take this contract ABI, which we have inside this tracking.abi. Okay, so this tracking is the folder, in that we have all of this data. From there we are taking the ABI. So that looks pretty fine. Now we can come here. Here we're going to build the function which allow us to fetch the contract, and that's the most important part. If we don't have the contract, we cannot interact with the smart contract. So let's write the function for fetching. So we'll say fetch smart contract. We'll take a variable called fetch contract, and in that we have to pass the signer or provider, like whoever is interacting with our contract. And in that we have to take this new ether package. We'll say contract, and then we have to pass the contract address, contract ABI, and the signer provider. In this way we can able to have the contract, and it will have the reference of the data of the user who is interacting with the contract. So this is the very first function we have, fetch contract. Now we have to come here, we have to export, because we are using context management for managing our entire state in our applications, and this one is really powerful, and if you are a beginner, then this one is really great for you to start. So we'll say export const, we'll say tracking context, and it's coming from create context React. So that's the export we have to do. Now we have to do another one. In this we have to create the provider, and in that we have to pass the children, and in that we're going to write the entire logic for our applications. Okay, so that's what I have, and you might not able to see the codes, the below codes, because I'm using an extension which hide the code from you. Okay, because currently I'm in the testing phase of this extension, that's why you are getting this behavior, but I can see it, but you guys cannot able to see that. Okay, so just follow along with me and type the exact code which I'm typing. And here the first thing I'm going to do is I'm going to define the state variable. So let's define that. We'll take a dApp name just for testing purpose. Okay, so this is the name we're going to provide, product tracking dApp. And now take the current address of the user, whoever will interact. And now we have to take this create shipment, and this is the function we're going to create. So let's call this async function, because we are dealing with a synchronous behavior, and in that we're going to take the data, the entire data for the current shipments, and that will come in the form of object. Okay, that's why I have taken this items. We'll take that. Once we have the data, we're going to simply console log out, so you guys can see that what we are getting, and we're going to deconstruct the data. So we'll take the const, and from this items, in this item we'll have all of the data like recipient, amount. So we are deconstructing that. So let's deconstruct receiver, pickup time, distance, price, and that's coming from items, because our create shipment needs these 4 data. So once we have the data, we're going to take this try and catch. So if anything goes wrong, we have to keep track of that. So inside that we're going to take this Web3 model, and we have to connect the contract with the wallet. So we'll use new Web3 model, and in that we're going to take this connections, await Web3 model dot connect. So once we have the connections, we have to take the provider, and that will get from the ethers, new ether dot provider. In that we're going to use this Web3 provider, and in that we're going to pass this connection. So this will connection the bridge. And now once we have the provider, we have to get the signer, and we have in this provider dot get signer. Once we have the signer, we can easily able to get the contract which we have in this fetch fetch contract, and that we have to pass the signer, because our fetch contract function needs signer or provider, and that's what we have passed here. So this will create a particular reference for that user who will interacting with the function. Okay, so we'll pass signer. So that's the entire connection from the user to the contract. So once we have built the connection, we can simply able to create the item. So we can call it create item, and in that we're going to call the contract a wait contract, and we have to call the function name we have in the contract. So in that we have to simply pass the data. So we'll pass the data to receiver, we'll pass the data to pickup time, and this time is going to be in timestamp, so we have to convert that time. Okay, so that's why we are using this new date, and we're going to pass this pickup time, and we'll say get time. So this will convert the time in timestamp. Okay, so we have converted the time. Now we have to take the distance, and we have to take the price, but here we have to convert the price in ether. We're not doing any transaction in way, we are doing in ether, although you can do in terms of way, but I will go with the ether term. So we'll say utils parse unit price ether, and we have to define the decimal points, and we're gonna simply provide the value, the amount, because the price and the value, they have to match. Then the transaction and the condition we have built, it will execute, otherwise the transaction will fail. So in that we have to pass the price and the decimal points, and that's it. Here we're going to simply call this create item await, because we have to wait for a few time once the transaction is written on the blockchain, so we have to wait for it. That's why we have used the wait functions. Once we have done that, now we have to simply check this console the items, and we're going to take this catch blocks if anything goes wrong, and we'll say when it's wrong something, and that's the entire function we have written for creating the shipment. So hope everything you have understood what we have done here and how we have written all of these logics. So that looks pretty fine. Now let's write the second function we have called get all shipments. So this will allow us to get all the shipments which the user will create in our dApp, so we can fetch it from the contract and we can display in our front end. So it's going to be an async function, we don't need to pass any argument into that. We have to simply make this try and catch block, and we have to take the provider, because we need a provider, and for that we're going to use this ether.provider then rpg JSON RPC provider. So again, I'm telling you, if you guys haven't watched the ether.js complete tutorial, and that I have explained every single thing about this provider, I'm using the functionality which comes with the ethers package. So we got the provider, and now we have to simply get the contract, and we have to simply pass the provider in our fetch contract. And the one thing you have to notice that when you try to retrieve data from the contract, you don't need to build the connection. Like in the other function, when we are creating the shipments, you can see that we are getting the signer, and that signer we are passing into the fetch contract. But when you try to get the data without making any changes in the state variable in the smart contract, you can just get the provider like this, and that's what I have done here. So we have the contract, and now I can straight away call the function. So we'll say shipments await, and in that we'll have the function get all transactions. This will give me all the shipments, and we have to simply map over it, because this data will come in the form of array. So we have to arrange the data. You can go without arrangement, but it will become very hard when you will render data in the front end. So it's always better that you have to rearrange the data the mode in such a way which you want to display. So let's rearrange that. So we'll say shipment map shipments, and it's going to be an object type. So we're going to convert the data into an object format. So the first one we'll have is the sender, and this data we have in this shipment.sender. Then we'll have the receiver, and we'll have the receiver. Then we'll have the price, and we have to convert the price into the form of ether. So that's how we can do it. We have the pickup time, we have to convert that into a number. We have the delivery time, we have to do the same thing with this. And we have the distance, convert that into a number. Then we have the is paid, whether it's true or false, so that's the one we have to get. And here we have the status, is going to be a status, and that's the entire data arrangement we have. So looks fine to me. Now let's come here, we have to return the entire data. So we'll have all shipment, and that's the thing we have to do. And now we have to simply close it by catch, If anything goes wrong, we have to throw the entire error message. So this is the message we want to display. And that's the second function we have for getting all the data from the contract. Looks fine. Let's write the third function we have called get shipments count. So this will allow us to get the shipment, that how many shipments user have done. So it's going to be async sync function, and again we are not making any changes in the state variable, so we don't need to pass any argument. We have to build the condition. So first thing we have to do is we have to get the wallet address. So we'll say window.ethereum return in install MetaMask. So if a user don't have the Ethereum object in the browser, that means he or she doesn't have any kind of Web3 wallet in the browser. So first thing we have to install the browser, then they can interact with the contract. So that's why we are making if statements. So once we're done with that, we have to simply get the accounts. So this is the way how we can get the account, and that we're going to call this method eth account. So this will give the account in terms of array. Once we have the account, we'll take the first account from this accounts array. But before we do that, we have to build the provider. So we'll say provider new. That's how we can get the provider, JSON RPC provider. And once we have the provider, we have to get the contract. We have to pass the provider into the fetch contract. So that's what we have here. And here we're going to call this shipments count await contract, and in that we have to pass the account address. Okay, and we're going to pass the first account. So this will say 0. So in this way we get the address of the particular user who try to know that how many shipments he or she has created. So that's the shipments we have here, and now we have to simply return the shipment count, and we have to convert it to a number. That looks pretty fine, and we have to check for the error handling as well. So error went getting shipments, and that's pretty fine. So that's the entire function. Very simple function. What we have done, first we have tried to identify whether the user has MetaMask or any other Web3 wallet or not. If he or she doesn't have it, then we have to throw the error message. If they have, then we have to simply get his wallet addresses, and we have to pass into our contract function so we can get the data from that particular user. So that's the function we have here. Now let's write the fourth function. We'll say complete shipment. So this will allow us to change the status of the shipment. So we'll say complete shipment, and that again we're going to take the data in form of object. So come here, we have to console log out the entire complete shipment data. Now we're going to take this const receiver index, because that the data will come in the form of object, and that's what we have to deconstruct. And these are the two data we're going to pass into our contract function. So let's come here, we're going to take this try and catch. We'll say if window.ethereum not there, then we have to throw the error message here. Now we have to take this const accounts, so we have to get the account of the user. So we're going to simply call the same method get eth account. So here we have the accounts of the user. Account of the user will say const web3 model, and we have to create the connections. And you can see that this time we are taking this web3 model because we have to make the connection, and this time we are changing the state variable in the contract. That's why we need a signer. Now we have to get the connection. So this is how we can get the connection, web3 model.connect. Once we have the connection, we have to take the provider from there, and we're going to use the ether package, and that we're going to pass the connections. Now we have to get the signer, which we have inside the provider. Once we have the provider, we have to get the contract, and that we're going to pass this fetch contract will pass this signer, and this will give us the contract. And we can come here, we'll call the function transaction await contract, and this is the function we have in the contract complete shipment. And now we have to simply pass the data. So the very first data we have to pass the account. That's what we need, the one who is trying to interact with the contract, the signer, the sender. Now we have to pass the receiver. This will come from the input, and we have to pass the index of the user. And here we have to simply set the gas limit. So one of you have asked me that when you try to call a functions where you are making the changes in the state variable in the contract, some of you are getting an error called gas limit. So this is how you can configure. Sometime it will throw you an error, sometime it will not. So in case you are getting an error, it always be a safer side for you to define the gas limit in the function. So I'm going with this gas limit. You have to check from your end that what gas limit it will want for your function. Okay, so that's the important things you have to keep in mind. So I'm providing this general gas limit. It works most of the time, but it will throw, if it will throw an error, I definitely play with this value to find out the perfect one for the gas limit. Okay, so that's the gas limit we have here. And once the transaction get complete, we have to say transaction wait, and we have to simply console log out the transactions, and we have to close the try catch block. Console log out the error, wrong, complete shipment, and error, the entire error object, and this looks fine. So this is the complete shipment function we have. Now let's come here. We're going to take the another function called get shipment. So this will allow us to get the data for the particular shipment. So in this we have to pass couple of data. So we need to pass the index. So we'll say console log index. We have to convert that into a number because we can't pass it as a string because it's a UNT variable. And here we're going to take this try and catch block, and we're going to need a account address, the one who's interacting. And once we have that one, and this is the same logic we have to follow to get the user address, user wallet address, and this is the method we have to call. So once you start working with these packages, you will remember all of the function, all of the method, and you can easily able to write it straight away without looking at the documentation. But if you are working with for the very first time, at that time you have to go through the documentation. So that's the account we have here, and now we have to get the provider, and we'll get it very easily. The same logic we have to follow here. Once we have the provider, we have to fetch the contract. We'll pass the provider, and this is the contract we have, and in that we have to simply call the function await contract dot get shipment, and in that we have to pass the data. We have to pass the account address and the index, and we have to multiply with 1 so we can convert it into a number. So that's the only thing we have to do. And here we're going to simply say shipment list. So again we have to format the data in such a way so we can display into our front end. Okay, and that's what we're going to do it. So we're going to take the shipment, and here we're going to simply take this sender is going to be shipment address. This is the receiver, and that we'll have the shipment index 1. We'll have the pick in time, we'll have this shipment index 2, and we have to convert this. We'll have the delivery time at index 3. We'll have the distance index 4, and we have the price. We have to convert it into ether, and that we have in the index 5, and that's the status we'll have in the 6th place, and the last one we have is the 7 paid. So this is how we can format the data. So if you console log out the shipment data, you will find that it will come in the form of array, and that's what we have done here. So we have taken the data from that multiple array, and we have formatted in a nice way so we can render in our front end. And we have to simply return the entire single shipment, and we have to simply close the catch block with this error message. Okay, so that looks pretty fine. Hope the entire thing makes sense to all of you guys. These are the very simple JavaScript logic we are building here to interact with the contract and formatting the data in the contract from the contract we are getting. Now let's come here. We have to build one more function which is called start shipment, and this function will call after the shipment is created, because no one can complete the shipment unless or until the shipment is started. Okay, so let's write the function. We'll say start shipment. It's going to be an async, and that we're going to take this get product. So we're going to have to need a product details to start, and we're going to take this deconstruct receiver and index, and these are the two data we need in our start shipment. We'll take this try and catch block, and in that we have to check for the account address, because we need the signer as well, the one who's interacting with the contract. So that's how we can get the address of the user who is interacting with the contract with this method eth accounts. So once we have the accounts of that particular user, and we're going to build this Web3 model, the connections. We'll build the connections, and we'll say web3 dot connect, the same old logic we are following here. So let me write it very quickly. Provider new ethers dot provider, and we have to pass the connections. We have to get the signer which we have inside the provider. Once we have the signer, we have to pass this in fetch contract signer, and that's how we can able to interact with the contract. Once we have the contract, we're gonna simply call that. So contract dot shipment start shipment, and in that we have to pass the data. So the data we have to pass is the account, the one who's interacting with the contract. the receiver, and we have to pass the index. We have to convert it into a number, and that's it. So once we have the data, we have to simply await for the transaction to be completed, and we're going to simply console log out the shipments, and that's the only thing we have to do. And we have to close the catch block. Sorry, no shipments, and the entire error message. And that looks pretty fine. Hope this thing makes sense. That's a simple logic we have built. Now let's write two common function for connecting our dApp with the smart contract: check wallet connection and connect wallet function. Now we have to write the most common function in the dApp which allow us to connect with the wallet. And if you guys want me to convert this function into a npm package, then do let me know in the comment section, so we don't need to write again and again the same function for every single dApp. We can convert it into npm packages, and whenever we want to call this function, all we have to do is to import the package and we can have that functionality. So do let me know if you guys really want, then I can build that npm package so you guys can follow that. And you guys will also learn that how to build an npm package in Web3 space. So let's write the function connect. We'll say check if wallet connect. So I'm going to write the function very quickly because this is the same function we have written almost 20 times in all the previous projects. So again, we have to check for the MetaMask connections, whether they have the MetaMask or not. Once they have the MetaMask, we have to get the accounts. This will be in form of array. So we're going to call the same methods ETH account, and once we have the account, we have to simply check for the length. So if account.length, if there is more than one account, then we have to simply set the account, set current user account to 1, the first account. Else we have to throw this error message, return this error message, no account. And that's pretty much. And then we have to simply close this catch block, and that's the only thing we have to do for getting the address of the user. So that's the function we have. Now we have to simply create a function which allow the user to connect the dApp with click function. Okay, so we'll say connect wallet. It will have this async behavior. Then we have to try and catch, and we have to check for the Ethereum object in the browser. And if we found that, then we have to if we don't found that, we have to say install MetaMask. Then we have to get the account, and this time the method we're going to call is different from ETH accounts. So this time the method we're going to call is called ETH request accounts. So there is a two different thing, okay, because this time we're going to make the request on click event, and that one is automatically run whenever the browser will load. Okay, so this time we are making the request on click event. So here we have the account. Now we have this set user account. We have to simply set that one, and we have to close this catch block, and we're going to simply throw this error message. So that's the current wallet function we have. Hope this thing makes sense to all of you guys. Now we're going to say use effect, and the first function we have to call is check if wallet is connected, because this function will call every single time someone will come to our dApp. So we'll say check if wallet connections, and that's the function we have to call, empty array. So that looks pretty fine, and now we have to simply return the entire function and the data we have created. And we have to take the tracking context, the one we have built above. We'll say provider, and inside that we're going to take this value, and whatever we're going to pass inside this value, it could be a function name, it could be a data type. That's all we have defined. That's all we're going to pass inside this value, so we can receive this in the entire application. So let's pass that one. So we'll pass the connection wallet. This is the function we have created. We'll pass the create shipment. We'll pass the get all shipment. We'll have this function called complete shipment. We'll have this function called get shipment, and we'll have this function start shipment, and we'll have this get shipments count, and we have this one dApp name, and we have the current user. So these are the function at the data we are putting into our context, so we can receive in our dApp. So let's simply come here, close this one, and here we're going to pass the children, because this will become because all the component we're going to define will be in the children, and we can easily able to receive the data. So that's the entire logic. So that's the children we have, and now we have to close our tracking context, and that's the only thing we have to do inside this tracking.js. So we have built the core functionality of our app. We have written all the functionality which is required us to interact with the contract, fetch the data, create the tracking, complete the tracking, get the tracking data, all of things we have done. So this is the entire data we have written. This is the fetch contract function we have, and we have this one. You can see this is the create shipment we have, get all shipment we have, get shipment count, complete shipment count, get shipment. We have this start shipment, we have this check wallet if connected, and we have the wallet connected. So we have written all of this function, and I believe that you guys have got the idea that how we have built the logic. Okay, so if you still have any confusion and doubt, make sure to rewatch the video. And again, I'm telling you that all the starter file is already provided to all of you guys, so make sure to visit dawlathussain.com. There you will find the starter file and you can have a look for all the assets. Thus looks here. Now we are done with this. Click here and we are done with the entire context, and now we have to do a little bit configuration before we move to the next part. So simply close this one, come back to the pages, and here we have to configure our provider, because this one is the most important things. So here we are in the app. Here we're going to write the internal import, and we'll say import that's coming from context tracking, and come back to the here, and here we're going to take this tracking provider, grab this one, copy this one, come back to the app, and here we're going to import it, and we're going to write the entire application with this tracking provider so we can receive and have the data in every single component. So we'll say take this block and we'll say tracking provider, and inside that we're going to take this component page props and remove this one, and that's the only setup you have to do, and that looks pretty fine. Now what we have to do is come back here, close this one, and come back to the component section, and now we have to create all the components file for our dApp. So let's create that in the components folder. So let's create the complete shipment.js. so this is the first component, and we have to type RAFCE, and this is the React functional based component we have created. So this is the first component we have. Now we have to create another one. This is the footer component, and this is the footer one, and now we have to create the third one. This is the form component, RAFCE. This is the footer for a form component. Now we have to create the get shipment component, RAFCE. I'm going a little faster because these are the simpler thing which we have done a lot of time in the past, and that's the structure I'm following. Let's create another one. This will become a navbar component. Let's create another one. This is the profile JSX, and come here, we have to create another one. This is a service.jsx. Looks fine. Now we have to create another one, start shipment. That's the good one. Now let's come here, let's create a table JSX, and I think we are done with this. Now we have to create one more file. This is called index.js, and that we index.js, yes, and that we're going to import all the components, and that's the approach I take. So let's quickly import. So let's come here. This is look good, everything's looking good. We have all the component which we need, and if we find that we need anything else, then definitely we can come and we can create that. So close this one, and let's come here, and I'm going to provide you this CSV files, because in this project we are using icons. So you will get all these icons and the images which I have used in this project in the starter file. So make sure to download that, which I will provide you in the website. Okay, so make sure to download it from there. So this is the folder in which I have all the CSV files. So I'll simply close this one, and if I open this, you can find that FOT1 means that's the icon for the footer. So we have 2 icons for the footers, 3 icons for the navigation, and we have 1 for the close icon. So all of this data is already provided to you in the starter file, so make sure to get it from there. So all of these things we have here. This is the icons we have, 2, 3. This is the cross icons, and looks fine. Hope this entire thing makes sense. And now we have to simply import that. Come back in index.js, and here we're going to import all the components including the CSV files. So let's import that footer component, and that's coming from there. Let's import the table, import the navbar, import the footer, and we have to import the service, import the profile. Let's import the get shipment, and we have to import the complete shipment, and we have to import the start shipment. So all of these components we have imported. Now we have to import the CSV files, the icons. So let me provide the CSV file. Let's import it, which we have inside the folder CSV folder / the navbar1, and that's how we can import it. Navbar2, then we have the navbar3, and we have to import the footer1, we have foot2, and the last one we have is this star1. And once we have the entire import is done, now we have to export the component. So we'll say export, and let's export that footer, table, navbar, form, service, profile, get shipment, complete shipment, we have the start shipment, and we have to export the CSV file, navbar1, nav2, nav3, foot1, foot2, and we have the service as well. So these are the entire import and export we have done, and it's become very easy when you export all the component which you need in your entire dApp and export it from a single location. So it becomes very identical, and you know that where you have imported and where you are exporting. So that looks pretty fine to me. Everything is looking good. No more issues we have here so far. Things look pretty fine. Come here, and this is the component we have. This is the app.js. This one is also looking pretty good, and here we're going to import the navigation navbar and footer bar, because that's the two components going to be in every single page. So let's import the navbar and footer. It's going to be in every single page. So that looks pretty fine, and let's come back to the component, and we're going to simply wrap that and come here, and we have to provide the footer down here. So that looks pretty fine, pretty promising. Close this one and come here into the index, and now we can start working in our index file. Okay, so before we start writing, let's have a look. Let's test this out, that everything's working or not. So what we're going to do is we're going to simply type npm run dev, and we have to open the application in localhost 3000, and you can see everything is working fine. We have no error. So our import and export is working fine. Our context is also set. We have the navbar, we have the index, we have the footer. Everything looks pretty good. This looks pretty good for me. And now we can start working in the component section. So we have built the entire architecture of our dApp, folder and file structure. We have done all the configuration. We have written the smart contract, we have built the folder, we have built the context, we have written the entire functionality, the core functionality of our applications. Looks pretty fine to me. Now close this one, come here, come back to the context, and here you can see that. So this is also done. We have written all of these functions, we have done all of these functions. Okay, so just a moment. That's the only thing I want to cover in this video, in the first part of this project. In the next part, we're going to start building the front end of our dApp. So hope whatever we have covered so far you guys have understood. If you guys found anything error, then make sure to rewatch the tutorial to understand everything. In the next video, we'll start building the front end, and we're going to connect all the function we have built. So let's move to that.